4 questions where we are modeling quadratic equations. Problem 1, we have 100 yards of fencing to enclose a rectangular region. We want to find the maximum area and the dimensions that result in a maximum area. So let's say we have a rectangle, and I'll call one side the length and one side the width. If I know that there's 100 yards of fencing total, I know that 2L plus 2W has to equal 100 because I have 4 sides of this thing. So what I want to do is I want to solve for one of these variables so that uh, I end up being able to replace one of these variables in an area equation. And so I know that, let's say W, for example, is equal to 100 minus 2L all over 2, which is the same thing as 50 minus L. So that means W being 50 minus L, I can replace the W's with 50 minus L if I want to not really think about having two variables anymore. And so now I have an area equation. An area equation is going to be L times 50 minus L because area is length times width. So I just take these two things and multiply them by each other. What I'm going to want to do in my calculator is I'm going to want to make A equal to Y and L equal to X if I use a calculator. So I'm going to want this to be X times 50 minus X if I do this on a calculator. However, since I've been doing this unit for a while, I actually don't even really need a calculator on this problem. I'm just going to use it for entertainment purposes and educational purposes for visualizing it quickly. But since I know that this parabola, if I graphed a sketch of it, the parabola would have x-intercepts at 0 and 50 because I'm in intercept form, and I know that my a would be negative if I actually multiplied this out and got 50x minus x squared. I know that my parabola is going to look something like this. Everything that's underneath the axis doesn't make any sense in the problem because I can't have a negative area since y is actually representing area. So my maximum area is going to be between the two intercepts at x equals 25. So I take 25 and I substitute it in, and I get 625 when I substitute it in. So my maximum area is 625, and this occurs with dimensions 25 by 25, and the area would be in feet square, or I'm sorry, yards squared. And then this would be yards and yards. So just confirming this on the calculator, um, I take x times 50 minus x, and I graph it. And if my window is standard, it's not very good. I don't really see anything. So what I want to do is I want to make sure that my window is good. Uh, -2 just to get a little bit underneath. And then I know my x max is 50 for this problem, so maybe a little bit bigger than that. My y min has to be something that's just slightly less than 0, so -10 works. And then I'm going to choose 700 just to get a decent look at it. So there's my graph. And once again, if I wanted to find a maximum value, I can hit second trace, maximum, make sure that my cursor goes above and below, and then it will give me the answer. Notice once again, just like the calculator objectives video, sometimes the calculator will have a rounding error. You would have to know that 24.999995 is really just 25. Question 2. The path of a football punted can be modeled by h equals -5t squared plus 15t plus 1, with h being a distance in feet and t being a time in seconds. We can actually answer all of these questions using a calculator, or we could do them by hand. Quickly, I will do them by hand. The highest the ball will be above the ground is going to be at the vertex, and that occurs um, at negative b over 2a, since we're given this in standard form. So that the x value of the vertex is negative b over 2a, so that's negative 15 over 2 times negative 5. So that is 15 over 10, which is 1.5. So the maximum height, sorry, I probably shouldn't use x here since this was given in terms of t and h. So the time is 1.5, and then I can substitute that value back in to get the maximum height, and I'm going to do that on the calculator. So if I uh, take this function and I graph it, my window is once again not very good. So I'm going to change my window. My x max, I can probably deal with 5, since if the vertex is at 1.5, it's probably not going to be very big. And then my y min, it's probably not going to be that high. So let's go 30 at the most. Yeah, that's way too big. But in any case, I can still see the whole graph. So if I go second trace max, I can find what it is, and it's going to be at negative 1.5. Then my y value is 12.25. So if I substituted the value in, I would get 12.25. So the time is 1.5 seconds, and the height is 12.25 feet. That's probably not that great of a punt, but it's okay, I guess. What was the height of the football above the ground as the punter made contact with the ball? That's 1 foot. That's very, very easy. That's the y-intercept. Notice that if I plug in t equals 0, that's the initial time. Part C. The punt was not fielded by the opposition. The football hit the ground. How long did it take for the football to hit the ground? This would be substituting 0 in for y, or 0 in for h in this case, and solving for t. So if I do that, I can use the quadratic formula if I were doing this by hand, but I'm not going to do that. So second trace, I'm going to find the intersection with 0. So that means I want to hit 2. Notice I'm not going to find the one on the left. I don't need to find the one on the left because that's not fitting the context of the problem. So I hit enter on both the left and the right of the 0, and it will give me the answer. So 3.065 will be the answer that I report, because that is rounded to 3 decimal places. So 3.065 seconds. Now, one thing to note is that the vertex was at 1.5 seconds. So we might in our brain want to think that my intercepts are going to be at 0 and 3. And yes, 0 and 3 would be equally spaced from 1.5. But remember that since there was a y-intercept of 1, that means that um, it's going to be slightly off of what we might think is are the like it's not going to be 0 as a y-intercept. I'm sorry, 0 as an x-intercept. Letter D, if someone caught the football 5 feet above the ground, how long after the punt was kicked was the ball there? Was the ball caught? So now we have to find t in this situation by substituting 5 in for h. And so if that's the case, I can create a third line, and that is the line y equals 5, and I can find this intersection on the graph. So once again, there are 2 intersections, and contextually we have to realize that we want to find the intersection that's on the downward part of the parabola. So I want my cursor to go toward the right, and I just need it to be closer to the one on the right than it is on the left. So I hit enter 3 times and I get the answer. 2.704 is the answer that I will report. So 2.704 seconds. What is the height of the football after 1.8 seconds? That's just substituting 1.8 in for t. And I can, again, do that on the calculator, because if I hit trace, as long as I'm on the red curve, as long as I'm on the parabola, if I hit trace, and then I just type in 1.8, and then I hit enter, it will, oh, I must have pressed the wrong button, 1.8, and then I hit enter. That will report the height that I'm given. So the height in this case is 11.8. So 11.8, this is feet. So 11.8 feet. Problem 3, Susan throws a softball from an 80-foot platform. So that means I have the point 080 on my curve. The ball reaches a maximum height at 2 seconds of 144 feet. So this is the vertex, and this is the y-intercept. So I'm probably going to want to use vertex form. So y equals a times x minus 2 squared plus 144. I substitute in some values. So 80 goes in for y, and 0 goes in for x. And now I'm going to solve for a. So I subtract 144 from 80, and I get negative 64 equals a times 4, since negative 2 squared is 4. I will divide, and I get a equals negative 16. Equation y equals negative 16 x minus 2 squared plus 144. And now I want to figure out when the ball hits the ground. So I want to replace y with 0. And now I'm solving. So I subtract 144. I divide by 16, and I get 9. I take the square root, and I get plus or minus 3. Then I add 2 over, so I get negative 1 or 5. Clearly, the negative 1 doesn't make any sense in the context of the problem. So 5 seconds is when the ball hits the ground. Problem 4. Jason is shooting a basketball from NBA three-point range. He's standing 24 horizontal feet from the front of the rim and releases the ball from his hand at a height of 89 inches from the ground. The rim is 1.5 feet in diameter and 10 feet above the ground. Jason shoots the ball and is headed in the direction of the rim. It does not miss sideways, because Jason would never miss sideways. If the vertex is 15 feet from where he shoots and 139.625 inches above the ground, is the ball likely to go in? So we need to think about what's happening. So the ball is released at a height of 89 inches, and the rim is 120 inches above the ground. The reason I know it's 120 inches above the ground is that 10 feet is 120 inches. The rim starts 24 feet on the x-axis from where the ball is released. And then there's a 1.5 feet, so this gets us to 25.5. So basically what we're looking at in terms of a graph is I'm going to make my x horizontal feet and my y vertical inches. And then I'm going to take a look at what's happening. So I know a couple points on the graph. I know the point 15, 139.625. I know the point 089 is where the ball is released. And so I can write an equation. So if I write the equation, I get y equals a times x minus 15 squared plus 139.625. I substitute in 89 for y and 0 for x into this equation. I subtract 139.625 from both sides and divide by 15 squared. And if I do that, I get a equals negative 9/40. So my equation is y equals negative 9/40 x minus 15 squared plus 139.625. Now my job is to figure out if the ball is likely to go in. So what that means is the ball is likely to go in if the y value, there are actually a couple different ways that I can think about this. If the y value reaches 120 when x is between 24 feet and 25 and a half feet. So I have two different ways of thinking about this. I can sub option one, I can sub in 24 for x and sub in 25.5 for x. I'm going to get two y values. And if 120 is between those two y values, then that means it's going to go in the rim. Or at the very least, it has a chance of going in the rim, depending on if it's, it hits the rim and bounces out or whatever. But it has a pretty good chance of going in the rim if the 120 is between there. Option two would be to sub in 120 for y, and then we will get x equals some number. And if x is between 24 and 25 and a half, then we will figure out that it's likely to go in. So what we're going to do is we're going to actually look at what would happen. So here's the graph. And when we find the intersection of these two things, so if I subbed in 120 for y, I would get 24.339 as my x value. So since that's the case, if I sub in 120 for y and I get 24.339, we would assume that Jason's shot is likely to go in, since 24.339 is between 24 and 25 and a half. My other option would have been to try to figure out what happens when x is 24 and when x is 25.5. So I could do that. If I sub in 24 for x, I get 121.4. And if I sub in 25.5 for x, I get 114.818. I think it was 114.819. That clearly 120 is between these two values. So that means that the ball is likely to go in the basket, which is not surprising because Jason shot it. But if Jason shot the exact same shot from 25 feet away, would the ball hit the rim? Well, I can change where the rim is by backing it up a foot. So if he shot it from 25 feet away, he would not hit the rim. It would actually be an air ball. And if you want a demonstration of what that would look like, that would be an air ball and really sad. But if the rim was in the original spot, it would go in. And this actually is kind of a big deal because that's why shooters in basketball can't shoot the exact same shot from everywhere on the court. They have to adjust. Otherwise, if they shoot the same shot from everywhere, they're going to miss a lot. So they have to practice from a lot of different spots in order to actually make it work out.